All right, so today we're going to talk about heat stoichiometry. And so basically what we need to do is we are going to be looking at a chemical reaction and figuring out how much energy is released based on the amount of each of the reactants that we're putting into the reaction. So things to keep in mind. Every reaction will have an energy exchange. Energy is exchanged when chemical reactions occur. And so they will give you a chemical reaction, and then they will give you this value. Delta H stands for enthalpy, and it's telling you the amount of energy that is either being gained or released when this chemical reaction completes. It is typically going to be in units of kilojoules. So notice how this delta H is a negative value. So that means that this is an exothermic reaction. If this were a positive value, then that would mean that it's an endothermic reaction. So other things about this. This is the amount of energy that is given off when we put in exactly 2 moles of sodium, when we put in exactly 2 moles of water, and we get out exactly 2 moles of sodium hydroxide and 1 mole of hydrogen. But unfortunately, things don't always work exactly as they should, and that occurs when we are not putting in exactly 2 moles of sodium. For the first problem, we're not putting in anywhere close to 2 moles of sodium. We are putting in 13 grams of sodium. So what we're going to have to do is do some rearranging of units to figure out how much energy is going to be given off if we put in this amount of sodium as opposed to 2 moles of sodium. So let's figure out how to do that. What we're going to do is we are going to set up a stoichiometry problem. So we're going to say that we have 13.0 grams of sodium, and we want to know how many moles of sodium we have, because that's going to change the amount of enthalpy, or the amount of energy that is being given off while this reaction occurs. So we go to moles by dividing by grams of sodium and going into moles of sodium. And so every 1 mole of sodium has a molar mass of 22.99 grams. So this is going to get us into moles. But what we have to do then is figure out, based on this number of moles, how much energy is being given off. So we're going to add on another conversion factor. So we said that when we have 2 moles of sodium, it gives off this amount of energy. So just like we've always done, we're going to make sure that our units align, and we're going to put moles of sodium on the bottom, and this time the question is asking us to calculate the heat. Well, this right here is our heat, it's our energy. So we're going to put kilojoules on top. Well, we know that negative 367.5 kilojoules of heat is released when we use 2 moles of sodium. So now our units are going to cross off, and we're going to be left with kilojoules for this amount of sodium. So go ahead and plug that into your calculator. All right, so the answer that I got when I plugged into my calculator was negative 103.9 kilojoules. So when we use this much sodium, this is the amount of energy we will give off. But we have to make sure we look at our significant figures. So in the problem, we started off with 3 significant figures. So that means that we're looking at this 3, and the 9 is going to round it up. So we're left with negative 104 kilojoules of energy that is released. So that's a fairly easier one. It's only like a 1-step problem. But if we look at this next one, it's going to change a little bit. We're still going to use the same reaction though. So it still says calculate the heat released when 10 grams of sodium reacts with 17 grams of water. So here I gave you a value for sodium and for water, and those are both of our reactants. So you should know that when you have 2 reactants, values for both of them, that means that you're doing a limiting reactant problem. So we have to figure out which of these reactants limits the amount of energy that can be made. So we're going to set up a very similar set of conversion factors for this problem. So we're going to say that we're starting with 10 grams of sodium, and we need to know how many moles of sodium that is. So we convert it to moles. So 1 mole of sodium for 22.99 grams of sodium. Now we're trying to get that into energy. So we go back up to our top and see that there are 2 moles of sodium for this reaction to create negative 367.5 kilojoules. And we're going to solve that. And we're going to set up something very similar for our other reactant. All right, so when I solve this, I have 3 significant figures here. So my answer should be negative 184 kilojoules. And now we are going to do the same process for water. So I start with 17 grams of water. I need to get that into moles of water. And now I need to get that in terms of energy. So I go back up to my reaction. I notice that I have 2 moles of water that produce this amount of energy. So I'm going to have 2 moles of water on the bottom and negative 367.5 kilojoules of energy on top. I'm going to solve this the same way. All right, so this one gives me negative 173 kilojoules. So if we understand what limiting reactants do, it's the reactant that's going to limit the amount of product that we can make. And so 17 grams of water makes a smaller amount of energy. So this is going to be your answer. Water was your limiting reactant.